Okay, let's begin. This is module number 7. We're going to start our second half into the world of Windows Server. We started talking about it in the last section, and in this section, we will spend our time working in Windows Server 2016. Server 2019 is a little different, but not by that much. A lot of the concepts, a lot of the tools, and things that we'll be talking about in this second half of the class, you will find in Server 2019. I suggest using Server 2019 instead of 16. If you do not have access to Google Cloud, please let me know, and I will send you a code so that you can mess with Server 2019 in the cloud and not have to run any virtual machines locally. So the server systems, uh, they they help with centralizing and managing a infrastructure. That's what's great about them, is that is their purpose. They could work as a desktop, but that's not the point of them. Their point is really to be a centralized location and handle information. That's why they're called servers. So a computer becomes a server when it has a network service for clients. Every server has a pair with a desktop, um, and they all are backwards compatible, which is kind of crazy. Like server 16 and 19 can work with anything up to server 2008. So because it's a server, it doesn't have a lot of the bells and whistles that Windows 10 has, because again, it's meant to really spend its resources watching or managing services and not really uh, playing games, for example. Their server core doesn't have a GUI, but gives you a command line or PowerShell, and that's all you have to work with. There's also the NanoServer, which basically strips any and all user interface together, and it's really just like an SSH system. Some of the network services that you have are listed here, but as you'll see when you work in server, you'll find a lot more things that you can provide to your network. So whereas Windows 10 only does Hyper-V, a few others, Windows 10 can only handle up to 20 logged on users. All this is thrown out because server can handle a whole lot more, including things like load balancing, clusters, RAID arrays, and all that. A server role is a major function or service that a server will perform. A role service will add functions to the main role. That can get a bit confusing, but one is a role, one is a feature. Their features will provide or enhance support to an installed role. So the role is really the big thing. The features are add-ons to those roles. Here's Server Manager, what it looks like in 2016. Again, it doesn't look that different in 2019. You can still click on Manage and hit Add Roles and Features. And you'll see the list of all the roles you can apply, along with which ones are already there. So some of the core tech, and we'll talk about this as we go through the chapters, like Server Manager, which we just saw, NTFS, which we've worked with, Active Directory, which we'll talk about, the MMC. It looks pretty much the same, functions the same, but will give you more add-ons because this is a server. You have disk management as always, your file and printer, networking, PowerShell, Hyper-V, and storage spaces. Server Manager is your main interface where you can do a lot of the server type functions. Provides you a nice summary. It's your dashboard. It's what you're always greeted with when you log in into a server for the first time, and subsequently, unless you tell it not to show up when you log in. NTFS sadly hasn't changed much since its introduction in the 1990s, but it's what Windows uses. The MMC, which we have talked about at length in Windows 10, so you are familiar with this. Disk management doesn't look that much different in server. As you can see, it looks just like it does everywhere else because all the Windows operating systems share a common core. You have file and printer sharing, which you already had in Windows 10, but server can handle many more connections at once and can do more than the desktop. Because we have a server, we really don't want to use the workgroup model. We really have the capabilities to create a domain now. So it is all centralized. That's one of the main reasons why a Windows server exists in a business, is to centralize management of the network. Of course, just like always, we have our network connections, whether it's our NIC and what protocols we're using. Don't necessarily need the other protocols, but Windows being Windows, it's backwards compatible. Now here we have all the protocols that our NIC will be able to handle. This is specifically looking at the Hyper-V network adapter. Nothing different from Windows 10. Just a weird wording, but just so you know, in Windows, the client software is client for Microsoft Networks. I don't know why it had to be that long. The server software is the file and printer sharing for Microsoft Networks. Active Directory is basically a big database that'll handle users, authentication. It'll handle adding desktops and servers into the infrastructure. It is your go-to place to manage users, groups, adding the group policies, all that kind of stuff all in one place. So of course it means this is going to be a target for attackers. So like I said, you can share across the network things like users, groups, shared printers, and so on. Authentication authorization can happen here. Kerberos can take advantage of Active Directory. Most often, we have DNS installed with Active Directory. And through there, we can assign the policies, deploy software, and assign permissions all through Active Directory. PowerShell, which you spent 2 weeks working on and under the wire, that's not going anywhere. If anything, it's become even more prevalent in Windows Server, especially in the cores and Nano, where you don't have any other tool to really use. It is equipped. It is there. So you will be using this throughout the course. That's why we spent 2 weeks on PowerShell. So you already had an in-depth experience into this. Hyper-V is here, since it is a Microsoft product. And Hyper-V is part of Windows Server. A lot of businesses who cannot afford VMware will use Hyper-V because it's already built in. So don't discount Hyper-V because you may end up using it more than you'll use things like VMware. Of course, we have different types of public clouds, and this is really harping to the whole cloud computing, where you could either do your computing locally or do it up on the cloud, and the different types of clouds that exist, like the public, the private, and virtual desktop. Storage spaces, a platform for creating those volumes that can be dynamically expanded in Windows. We could use RAID volumes. We could use different types like USB, SATA, SAS, internal, external. Some new features in Server 2016 that were later moved on to 19 are all of these. Like NanoServer, the server that doesn't have a GUI at all. The storage spaces, nested virtualization, where you can virtualize another VM within a VM. NanoServer, again, is geared towards running VMs, not intended to be a full-fledged server. Has no real user interface except for the recovery console. This little guy is meant to do just a few items, like running an application server, file server, web, DNS, and a bit of processing. This is what the console looks like. Not much to do at all. You could do containers like Docker type containers within Windows, although I've seen that it's pretty hard. It's more complicated to do it in Windows than in like Linux. We can use software-defined storage with storage spaces direct. We do storage replica to make backups of our storage in case of a disaster or in case of a failure, which, as with hardware, it's going to happen. It's always a matter of when, not if. You could manage VMs directly from PowerShell using PowerShell Direct. And again, we're going to talk about this later. And that's the virtualization running VMs within a VM. That is another possibility of the servers. Chapter 2 will cover installing Windows Server. For those of you running Windows in the cloud, this is not a problem at all because you just select what VM you want, and in less than a minute from a template, the operating system is there. If you, for whatever reason, have to install it locally, this chapter will be for you. Just like the desktop, we have a couple of server editions: Data Center, Standard, Essentials, Multipoint, Storage, and Hyper-V. Data Center can install an unlimited number of VM instances with Hyper-V, of course. It has a couple of features that don't exist in Standard Edition. These 4 that are listed. Standard has most of the features, except the ones mentioned earlier. It only supports up to 2 VMs or Hyper-V containers. So again, it depends on what you're going to be using the server for. That will determine which edition of Windows Server you'll use. Another limitation will be the budget, because server licenses are not cheap. Essentials are for small businesses with 25 or fewer users. And it has some basic services that are used at that level. The Multipoint Premium server is volume licensing, mostly used in academia. Windows Storage, basically making a server into a NAS. And Hyper-V, the free, where you can run virtual machines. The standard licensing model is based on, instead of processor-based model, each processor core must be licensed for up to 2 physical processors with up to 8 cores each. That is something you have to keep in mind of how the licensing structure works. Because you might be in for a surprise if you get a server that has more cores and, oh, the price tag for this is higher, or, oh, I can't access these cores because the license doesn't let you. That's how they get you. your minimum requirements for running Windows Server. Again, if we're installing locally, it's going to require some planning. It is not just something you do haphazardly, because servers tend to be an essential portion of the network. You want to ensure you have the right CPU, enough cores to do whatever work is going to be set. Obviously, you should not have any 32-bit processors anymore. Should all be 64. Other things to consider are things like the following. The name of the server, because again, this has to be unique. The protocols that'll be used, the IP address that'll be statically assigned. The server should have a static assignment. Will they be joined to a domain, and what roles this server will have? A clean installation is just the same as installing Windows. The process is pretty similar. The default install is server core, so keep that in mind. When you install Windows Server, you might, if you're not paying attention, you might end up installing core and not the one with the desktop experience, which is the GUI that we're all used to. Notice it doesn't say core. It just says standard. That is the core. If you want one that has a GUI, you use desktop experience. And this portion, again, is the same as you would in any other Windows system where you set up the path. The one difference is you do have to set up a administrator password. And then it'll go through that process. There's where you enter the admin password. Just in case you installed the wrong edition, you could just use this command to change it. Because the core of the operating system is the same, no matter what edition, it's just the roles and features that you can use. It is possible to switch. As long as you have the right product key, you'll be able to make that switch. Becoming more rare if a disk isn't found, because the drivers are normally now native to the OS, but just in case, you'll need to have the right controller driver, just in case it doesn't show up. And then, of course, after you install, you'll need to activate Windows, set the time zone, set IP addresses, all that kind of stuff. And, of course, updates. Cannot forget to install updates to a system that will be critical to your network. Updates could install on their own, or you could set a schedule for them, but Windows forces you to install updates no matter what. Once all that is done, then we can go ahead and start setting up our server, whether installing the roles and features that are necessary, or if we're going to turn this into a Hyper-V system, install that role. If we're adding a new server, if there's already a DC, a domain controller existing, then we'll add this server into it, or make it become a domain controller, or just set as a standalone server. Adding servers into our network is important if we're growing our company. If there's already an excessive load on existing servers, then we'll need more servers to handle that traffic and load balance together. If we need to isolate applications, fault tolerance, or we're adding a branch. These are all reasons why we would need to add another server into our network. If we're upgrading, you can either do an in-place or server role migration. The in-place, again, it needs to be at least server 2012. Migrating from earlier versions, you could do it as far back as Server 2008. Again, Server Core has very few roles. It will most likely depend on another server to be the domain controller. If you want to use any of these, you're going to need to use the desktop experience and not Server Core, because Server Core doesn't have these functionalities. Same with all of these. Server Core installation is the same as the usual Windows install. The only difference really is choosing the edition that doesn't say desktop experience. And then just as always, you'll install, configure the time, the IP address, the firewall, all that kind of stuff. Server Core should not be your first server on the network. It's more of a secondary type. If you cannot live without a Windows GUI, then you really should use desktop experience. But more and more, Windows is becoming less GUI-like and becoming more like its Linux counterparts. So I would suggest to be well-versed in PowerShell like you have been doing the under-the-wire stuff. I would highly suggest being well-versed in PowerShell, especially if you know you're going to be managing Windows servers. Again, like I said, all the Windows editions are pretty much the same. They have all their features and roles installed in this folder. So it is possible to do features on demand because that's where they live. These files should not be removed. If it's taking out a lot of space, there is a way to remove the features. And then later it is possible to download features. Here's a list of them as shown in PowerShell. And then selecting some that are installed. You could use this first command to remove all available features to regain space. Because like I said, this folder does have those roles and features, but it can get pretty big. Because there are a lot of things that server can do. Your feature file store, a network share containing those files required to install the roles, role services. So if you have a primary domain controller, it has plenty of storage, it could be the one to hold it all. All the other subsequent servers, well, they could just use this command down here in order to install. That way, all your secondary servers don't have to have all the files. They can just pull it from one location. And this last chapter will start the configuring and managing of Windows Server 2016. Like I said, roles and features are the basic functionalities for Windows Server. You have to add roles and features in order to take advantage of what server can offer. Most of them can be added and updated through both the GUI and Server Core. Through the GUI, it is in Server Manager. That's where you add roles and features, update, manage all that kind of stuff. Here's kind of the GUI for you begin, And you could skip this. You could either do role-based or remote desktop installation. You select what server from a pool when installing these rules and features. This could also be installing on a virtual hard disk, a VHD file. Now, where are we installing this new role? Then all the roles available will be listed. You check the box of, do I want to install all of file and storage services, or do I specifically want to install one thing? With those that don't have a submenu, it'll be just that whole service. The features window works just the same. So if in this case we're installing remote access, then there will be a couple of services that go with that. So for installing remote access, what do we want? A web application proxy, routing, VPN, or all three, or one of them, two of them. You can select that there. Then you get a nice overview of what we're going to install. We could also have Windows Server restart automatically if that is necessary. To remove, it's pretty much the same thing, same wizard, just in backwards function of choosing what role, unchecking it, and then going through the process to remove. In PowerShell, you can do the same thing. You can use PowerShell on remote systems in order to install a role. You can also work with offline images like VHD files. They can be used to install or uninstall features. The desired state configuration, kind of like a template. We can push a DSC into a server, or we could pull one that we're gonna send and make those changes and make basically like a template and say, all right, if these servers need to have these roles set up this way, we can do that in one shot. DSC script is created the same way with PowerShell in the ISC. So when you open that, you'll create a management object file, or MOF. The local configuration manager will handle either sending or receiving these configurations. Servers can be managed remotely using things like the MMC if you are on the network, or remoting in from the outside. You can add servers into Server Manager to do it all from that one interface. Like I said, it's backwards compatible. So you could do all the way up to Server 2003. You would just add them in, and then you can manage them from Server Manager. Within that, you can handle things like making groups. So you could split things up by like departments or geographic locations or server type. WinRM came about in 2016 to help you manage your servers remotely. You just have to enable remote management and enable WinRM. You go in your local server, you'll find it on the left-hand side. If you're going to use MMC to manage a remote server, then you need to open up a couple things in the Windows firewall. So you need to enable these rules. and that's where they are. You need to allow them in order to get the MMC to connect to another server. If you want to do this through the command line, you can do that right here, or use a PowerShell as well. Server core doesn't have COM+, and firewall rules for different MMC snap-ins, you might have to do them separately and set firewall rule groups in server core. With Server 2016 and above, we can use the Windows image deployment. This role facilitates installing Windows across the network. You can use a pre-boot execution environment. That would be where a VM who goes on the network will find we'll get an IP address, and we'll find out, oh, I need to get my image from this location. And then it'll go there, boot that image, and install it. Of course, you'll need to have a Windows image as a WIM. Windows PE can be used to jumpstart a Windows installation. You could do multicasting to install to multiple machines at once. You could do a network boot or a bootstrap program. WDS requires at least Server 2016 and all of these items. Once again, you could either use the server manager or use PowerShell to install this role and feature. As with any role, you have to do some configurations. You can integrate this with Active Directory or do this as a standalone system. Of course, Active Directory is the default and is recommended. You can set this as unattended so that it does it all on its own. Here's the wizard. That'll say, okay, if we're going to do this, you know, what services we need running. Do we want to integrate this with Active Directory or run it on our own? Then we'll decide where the boot and install images are going to be located, the Pixie boot files, and any management tools. If this server is not the DHCP server, then you'll need to configure your DHCP server properly. Otherwise, you could just do it all in one. There's the Pixie server options. Once it's installed and configured, now we can work with images. So with these images, we can run them across the network, and we can do multiple installs at the same time, making our life easier. You'll need a boot image in order to have these machines boot at once. So for example, if we want to take care of a lab, we don't want to really touch every single system, but we could use WDS to deploy to all. And of course, you need a boot.wim to start the boot process. We'll need a capture image. So we install Windows on a prototype or on our golden system. We do all the configurations we want, and then we can use the capture image to create the file that we need that we'll use to deploy out to everywhere else. You can use the system preparation tool to help you out with that. Once it's all ready, you can turn it into install.wim. That's what will be used to install into all the systems that will be receiving this image. Of course, you can use a stock Windows install, but ideally you want to pre-configure everything so that when it does get rolled out, everything's installed with it. You can update these images. So it's not a set once and done. You could have your main image and then later update as you get more updates or as you install new applications, make configuration changes. You can update it and then send it out. You can enable and disable features within it. Of course, you have to take it offline and then make the changes you need. Again, because you can install and uninstall features and roles into VHD files, it is possible to do that with this. Of course, you can do all this with PowerShell. And next we have our services, our background processes that help us do things like connect to the network, print, DNS resolvement, all that kind of stuff. It is just the same as with Windows Desktop. You can just get to it from a different place in the server manager, but you can also do services.msc and you'll land at the same thing you've seen before. So just like Windows Desktop, you can get to this and make the changes you need to a service like DNS. Just the same. And in case the service fails, what will it do next? Any dependencies? This is all the same as you would see in Windows Server. And of course, you can manage your services through PowerShell. Not very much different because again, these Windows Server and Windows Desktop share the same operating system core. So there's going to be a lot of overlap between the two, which in a way is great because it helps you become more familiar with the Windows operating system in general, and you're not really learning a whole nother system from scratch. Like if we were talking about Windows and suddenly we switched over to BSD, it's not that different.